Alright, this is going to be a very quick, nasty, quick forces review. So first off, what's the symbol we like to use for forces? Well, it's a capital F. Okay? We tend to put subscripts down here to specify which force we're talking about. So force 1 or force 2, or sometimes we'll name it like this. We'll go force of, let's say I was lifting a book, that would be the force of vulcaning on the book. Okay, we did that last year. I hope that you remember. Okay, moving on. The units. Who remembers? Is named after that dude that everyone just like invented physics. His name was Newton. So the units are newtons, which is denoted by a capital N. There's no dot over that. That's just a little typo. Okay. Alright, what else? In general, forces all add together. So let's say I had, well, I already talked about a book. Let's just do that. I say I had a book, which I denote in a free body diagram, remember those things, as a dot, and then you draw the forces as arrows. If a force is pulling down on the book, you would start at the book, the dot that represents the book, and you put an arrow that points down. Okay, like say the force of gravity, for instance. Okay, it might be sitting on a table, so the table would push up. Force of okay, we call that the normal force. That brings up some interesting naming, some special names. Whenever you have a surface pushing up on something or sideways or whatever, it's basically whenever a surface pushes on an object, it's reacting to that object pushing into the surface. We call that the normal force. Normal force. Okay, normal not meaning, that doesn't mean like average or something. It means normal as in perpendicular. It is perpendicular to the surface. Okay, we did this last year. This is only review. Perpendicular to your surface. So if you tilt that surface, okay, for example, if I had a wall, oh, and it's a crooked wall, even better. I had a wall, and for some reason, I have no idea, why would you push on the wall? Oh, I know. You know those kids that are always late to class because for some reason they think they need to stick their butts up against the wall and lean on it. And they usually have like their arms crossed in front of them, and there's probably some earbuds in there or whatever. Okay, they're holding up the wall. I guess the wall really needs the help. The force of the wall on them is equal to the force of them on the wall, and it would be kind of that way because that is perpendicular to the wall. Okay, normal force. Notice normal force could be written Fn or just a capital N, but people tend to not like this one because it looks too much like a Newton. Yeah, and it does. I've seen it both ways about an equal amount of time, so I will be using both kind of interchangeably. Anyway, back to the book. The force of gravity is down. Let's see. And then let's say I'm pushing on the book. I'll push left. I'm trying to shove that book to the left. That would be the force of vulcaning on the book. Now I'm going to give them some numbers so we can do a little bit of math. Make this, say, 3 newtons. Oof, boy, my handwriting's horrible today. I'm sorry. Make both of these 2 newtons. Okay. The law of superposition says that this book is experiencing all those forces at once, and we could equate all those forces at once to one force we call the net force. So the net force is what you get when you add these up, but you have to add them as vectors. Now luckily you guys just got done adding a bunch of vectors up. The easiest way to add vectors up is to do them in each dimension separately. So for example, I could do the net, F net, is equal to the net force in the x direction as a vector plus the net force in the y direction as a vector. So I have to get each one separately. So I add up the stuff in the x direction, which is, well, I've got 3 to the left, and I've got nothing on the right. So that's going to be, let's see, F net in the x direction is just going to be -3, like that. And then I add them up in the y direction. The net forces, the total forces in the y direction, I've got 2 up minus 2 down. You always do, crossed the virtual page crack here, sorry. I add those. I always do up is positive is what I've decided, so up is positive and then minus anything that's negative. And I end up with 0. So the net force total would be what I would get if I added up 3 to the left and 0. Well, that's just going to be 3 to the left. 3 newtons to the left. If this wasn't 0, let's say I had 3 and like, I don't know, 5 or something, I'd have to use the Pythagorean theorem because they're not in the same dimension. I'd have to do 3 squared plus 5 squared, and I'd square root it and be all nasty and stuff. Yeah. Anyway, quickly, more stuff. What else can I talk about? Oh yeah, how about this guy down here? Let's talk about him. Force of gravity. Force of gravity is always denoted as capital F, little g, like that, and it is the mass of something times the acceleration of gravity at the Earth's surface. You guys have been using that in the last unit. It's 9.8 meters per second squared down on Earth, but notice that's not the same on other planets. Mass is, though. My mass is the same no matter where I am or what's going on. It is an intrinsic value. Like, I have a mass of like 62 kilograms. Doesn't matter if I'm here on Earth or floating around in space or like on the moon or whatever. Doesn't matter. But my weight, by the way, another name for this, weight. Oop, come on, that's a G. My weight depends on what planet I'm on because little g depends on that. By the way, sometimes, and I hate this, but sometimes people will write weight as a capital W. Sometimes with a vector sign, sometimes not. I don't like that because W also stands for work, and it gets confusing. And this is perfectly good. I want you guys to use this. It's much, much easier. Yeah, I know what it means. You know what it means. Just go with it. But if you see this show up in your homework or something because the stupid textbook uses it sometimes, that's what it means. Just keep it in your head. Some other special symbols, some other special forces that you should know about. Actually, yeah, the last one in our next lecture will be on this too. Friction. Friction is a force. It is. But it's a special force, so we use the symbol lowercase f, and we do it kind of scrolly-like. Scrolly. Yeah, work it, F, go. Okay, if there's more than one friction, we'll tend to number them, F1, F2, F3, whatever, make a rap song. And, well, let's do that one next.